The question is, an external pressure P is applied on a cube which is at 0 degrees Celsius. So it is equally compressed from all sides. K is the bulk modulus of the material, which is the cube, and alpha is its coefficient of linear expansion. Now, suppose we want to bring the cube to its original size by heating. So by what temperature should it be raised? Now, how to solve this? We know that K, which is the bulk modulus, is equal to delta P upon change in volume, the rate of change in volume. Therefore, the rate of change in volume will be P by K. Therefore, V equal to V naught 1 plus gamma delta T. If you multiply V naught on the inside, you will get V naught plus V naught gamma delta T. Then take V naught on the left side, V naught plus V naught gamma delta T. Now take V naught here, we will get this V minus V naught equal to V naught gamma delta T. Now divide both sides by V naught. V minus V naught will be delta V divided by V naught, which will be gamma delta T. From the previous equation, we know that delta V upon V is P by K. Therefore, gamma delta dV will be equal to P by K. From here, we can find delta T, which will be P by K gamma. K into gamma. Now, which will be P. K is the bulk modulus which was given, and gamma will be 3 alpha. So this is the correct option.